Hello James, welcome back to another video. So behind this video, recently we discussed the frequently asked bit set questions from the chapter of laws of motion, and there we saw that 2 out of every 3 questions which were based on friction were from block over block system. Now this is also an important topic for other competitive exams too. So we will discuss the block over block systems, understand it today and solve such problems in the simplest way possible. Okay, so let's get to this video. So firstly, let me explain you what this whole debate is about. So today we are discussing block over block questions in which one block will be placed over another. Okay, the masses of these two blocks will be given. The coefficient of friction will be also given. Okay, the question over here is that what is the maximum force with which this block should be pulled so that both of them move together. If you see over here, if I move slowly, both of them move together. But if I give a greater force, right? If I give a greater force, they will slide, right? So the question is, what is the maximum force that can be applied to this block so that both of them move together? Okay, I hope the question is simple. I hope you understood it. Let's follow the steps over here. These are the 4 steps that you need to follow in order to solve such type of questions. Okay, so coming to step number 1, step number 1 is just to draw FBD. Now FBD just means free body diagram. Okay, so you have to draw the FBD for mass A and mass B. Okay, so FBD basically shows all the forces that are acting on that particular block. Okay, now coming to step 2, now don't worry if you even if you don't understand the procedure over here. When we'll put it into practice, when we'll practice the questions, then you'll be able to see it in action and then you'll be able to understand it. Okay, now coming to step number 2, find maximum friction, the limiting friction between the two blocks. Now why limiting friction? Because if you see here, we are asked for the maximum force, right? Now when this force is maximum, right, um, the friction that is acting between the two blocks will be also maximum, right? Because if suppose you know that the maximum force that we should apply for this system, okay, suppose you know it already, you know it that it should be 40 newtons. Okay, so if I apply 40 newtons over here, the case will be like this, right? Both of them will move together, right? Because that is the maximum force at which both of them move together, right? So 40 newtons, this is the thing. Okay, now what will happen if I apply 50 Newton? If I apply 50 Newton, it will slide, right? If I apply a greater force than F max, the two blocks will slide, right? There will be relative motion between the two blocks. Okay, so what is happening is that at F maximum, the friction between the two blocks is also maximum. Beyond F maximum, if you go beyond 40 in this case, the friction will not be able to support it, right? So at F maximum, the friction between two blocks is the maximum friction or is the limiting friction. Okay, so that is the reason we find this limiting friction between the two blocks, because that is the maximum friction that can support this type of motion. Okay, so once we find this limiting friction, we'll just use FL, we'll just write F equals MA. Okay, we'll have one block in this case that has only the frictional force on it. Okay, you'll see that at least one of these two blocks will have the force that is only acting on it. The only force that is acting on at least one of this block will be only the frictional force. Okay, we'll find that block, we'll write F is equal to MA for that block. Okay, we know that the force on that block is only the frictional force, M into A max. We'll find A max over here because mass is given, frictional force we have already found out. Okay, so how will you find this limiting friction? First of all, you'll just use mu into N. Okay, this mu into the normal force on that particular block. Okay, now coming to step number 4, again very simple, you'll just write F net is equal to MA, right? F net is equal to MA for block 2. Now this is block 1. Okay, the block on which only frictional force is acting, that is block 1, and block 2 is the other block. Okay, so yeah, we'll write F net is equal to MA for block 2 and we'll solve it and we'll find this F maximum. Okay, so that is the whole idea behind this block over block type of system. Let's get to questions now. So let's put this to action now. Okay, so here we have a block over block system. As you can see, the masses are given. The coefficient of friction between the two blocks is 3/7 and the coefficient of friction between this block and ground is 0. Basically the ground is frictionless. Okay, here you are supposed to tell, again the question remains the same, what is the maximum force with which you should pull this block B so that both of them will move together. Okay. Now step 1 is very simple. We are just supposed to draw the FBD. FBDs mean free body diagram, right? Just show all the forces that are acting on a particular block, right? So let us choose block A over here. Okay. So if you see, the only force that is acting on this block A is the force of friction. Okay, let me convince you on that. Okay. So here we have this block over block system. When you pull this block, okay, when you pull the block B, both of the blocks should move together, right? According to the question. Okay, so according to the question, when you pull this block B, both of the blocks move together, right? So why did block A move when there was no force on it? Because there was force on it. Okay, there was a force of friction between block A and block B. Okay, which and due to that, it is moving together with block B. Okay, so when you pull only block B, there is friction between block A and block B, and due to which the block A is also moving together with it. Okay, so there is a force of friction on this block A in the forward direction, right? So that it is moving together with block B. Okay, and there are no other forces on this in the horizontal direction, but there are forces in the vertical direction. There will be a normal force due to this contact over here. There will be also its weight mg acting in the downward direction. These two forces are balanced. There is no motion in the vertical direction, right? Now coming to block B. Now block A, it's very simple, right? Only friction force is acting on it in the horizontal direction. Okay, let's come to block B now. Now for block B, we know that we have applied this F max, which we are supposed to find. Okay, is there any other force acting on it? Okay, let's neglect the forces that are acting in the vertical direction. We know that there is no vertical motion, right? So let's neglect the forces acting on B in the vertical direction, right? There is no vertical motion, only that logic. Okay, so let's see only the horizontal motion. Okay, so if you see F max in the forward direction, is there any other force in the horizontal direction? You might say there is no force, but actually there is. Okay, because if you see, there is a tendency of relative motion between the two, right? So when there is a tendency of relative motion, there should be a frictional force, right, which will oppose this motion. Okay, and there is a frictional force on this block B, which is in the opposite direction, right? Actually, you can see it by Newton's third law. Every action has equal and opposite reaction. So here on this block, we have friction in the opposite this direction. Forces exist in pair, basically by Newton's third law. So there should be a force of friction on that block due to this block in the opposite direction. Okay, forces exist in pair. Okay, so yeah, equal but opposite. Yeah, so yeah, so here we have block B, here we have block A. Okay, and if you see, now step 1 is done. Okay, we have drawn the FBD. Let's come to step 2, find frictional force, the maximum frictional force, the limiting friction between the two blocks. Okay, and for this you have to choose that block on which the only force acting is the frictional force. Okay, only see the horizontal direction. Okay, so choose that block on which the only force is the frictional force. Okay, so if you see this one, block A, the only force acting on this is the frictional force. N and mg are balanced, no vertical motion. Don't see the vertical motion at all. Okay, so if you see, the only horizontal force acting on block A is friction. Here you have F max and minus friction, right? But only if you see block A, the only force is friction, right? So you can write for block A, okay, you can find the limiting friction over here using mu into n, right? The value of limiting friction is mu into n. Okay, so mu value between the surfaces is given as 3/7 mg. N is nothing but mg, right? Because n and mg are balanced, n equals mg. So m into g, m into, so this was the only purpose of writing this the forces in the vertical direction. Okay, here there is no use, so I didn't write those. Okay, so n equals m into g. What is the mass of this block A? Block A is 0.5, and g will take it as 9.8. Fun fact, 7 and 9.8 are multiples. So yeah, you can cancel this. 7 1 is 7 and 7 4 are 28. Okay, so yeah, we have to multiply this. 3 5s are 15, so 1.5 into 1.4. Okay, so 15 15, 2 to 5, 2 to 5 minus, I guess, 14, 2 to 5, minus 15 it will be. Okay, let us do that. I think it should be 2.1. Let's try it. 4 5s are 20, 4 1s are 4, 5 6, yeah, 15 4s are 60, and here you'll have 15. Okay, so this should be 11. Okay, and yeah, 2.1. Okay, 1 2, so 2.1. So the limiting friction between these two blocks is nothing but 2.1 Newton, right? So we got this. Step 2 completed. We found the limiting friction between the two blocks. Okay, now we can write this limiting friction as m mass into acceleration, right? The only force on block A in the horizontal direction is the frictional force, right? So F net is equal to m into A. F net is equal to the frictional force, the limiting frictional force. This will be the limiting frictional force because I told you at F max the force acting between the two bodies is nothing but the maximum value of friction, the limiting friction, right? So FL equals m into A, okay, or A max will write, okay, because this is the maximum friction that this is the maximum acceleration that your friction force can provide, okay. So yeah, FL, it's 2.1, okay. M mass of this block, okay, for this block you can see the mass is 0.5, okay, fine. And A max is something we are supposed to find, right? Step 3, find A max using this relation. Okay, let me number the step. This is step 1, step 2, step 3, okay. So 2.1 divided by 0.5, that is like multiplied by 2, so 4.2 meters per second square. That is the maximum acceleration that your friction can provide, okay, and is providing in this case. Okay, let's come to the final step. In final step you are supposed to choose the other block. Okay, now so far we have considered block A, right? We calculated FL using block A. We also used F net is equal to MA on block A. Now you are supposed to use F net is equal to MA on block B. Okay, and if you see, F net is F max minus F, right? F max minus the frictional force, or here the limiting frictional force, pairs, right? So yeah, this will be equal to m into A. Now m stands for mass of B, right? We are considering block B into the acceleration A. Now if you see, the question says that find the maximum force when the two blocks are moving together. If they are moving together, their acceleration will be the same, right? Because they begin from rest, and in order to move together, their acceleration should be the same. So here the acceleration that we are going to use is this one, and here you'll have your answer, okay? Because you know F max you are supposed to find. FL we have already found out what's happening, okay. Minus FL we have already found out, it's 2.1, okay, fine. MB, mass of B is 4.5, 4.5, and acceleration is 4.2, okay. And when you solve this, you'll have your answer, right? And the answer, I'm not going to solve that, please solve it. I guess the answer is, let me check that, it's 21 newtons, okay. When you solve this, you'll have your answer as 21 newtons, okay. I hope the approach is clear. At least you could fetch some things from here, okay. Let's practice one more similar type of this question, and then we'll go on leveling up, okay. So question number 2, again a very similar question, only difference is the ground also has some friction over here, okay. So that will only make some difference in step number 4, otherwise it will be similar, okay. So let's try it. You can also pause over here and try it for yourself, okay. Discover the joy of doing it yourself. You also have the approach in front of you, okay. So step number 1, draw the FBDs. Let's name this block A and this block B. So if you see block A, the only force acting on it again is the frictional force, right? Find the maximum force so that both of them move together. They move together because there is a frictional force on block A which is helping it move together with this block, okay. So frictional force acting in the forward direction, and since this force is maximum, here the friction force is the limiting one, okay. Now this is block A, right? Now if you see, the normal force will be also there on this, and its weight in the downward direction, right? Normal force due to the contact, and it balances its weight mg. Okay, so no vertical motion, n equals mg. Okay, now let's come to block B. If you see block B, again we have the force that we have applied, which is the F max force that we have applied, and the second force acting on this one will be the limiting friction force, right, due to this block. Okay, forces exist in pair. Okay, Newton's third law, and equal and opposite, right? They are equal in magnitude and opposite in direction. This frictional force is opposing the motion of block B. Okay, now let's also write the forces that are there in the vertical direction on this block B. Previously we didn't write it because we didn't have to consider the friction between this block and ground, right? Here we have to write mu n for the friction between this force, this block and ground, right? So let's write the normal force over here. Okay, there will be a normal force due to the ground. This is n. Okay, and this normal force will balance the weight of both the blocks, right? This block and the block that is kept on top of it. Okay, so this normal force will be equal to ma plus mb into g. This normal force due to the ground will balance the weights of both the blocks. Okay, so yeah, that is what I have written. Okay, no vertical motion, this force equals this. FBD drawn, step 1 complete. Okay, let's come to step 2. Find the limiting friction and choose the block on which the only force is friction. Again, it's the block A, the block on top. So it's block A, FL, you have to write it as mu times of n. Okay, find the limiting friction between the two blocks. Okay, so between the two blocks, the limiting friction, the coefficient is 0.2, right? And n equals mg. We are writing it for block A. Keep that in mind. Okay, this is for block A, right? Because choose the block on which the only force is the frictional force, right? So yeah, so n for this is m of mass of A into g, right? Mass of A into g. So mass of A is 1 into g is 10. Okay, fine. So 0.2 into 10 is 2. So the maximum frictional force is 2 newtons. Okay, so yeah, so we have found the maximum or the limiting friction. Next step is to find the maximum acceleration. Again, block A, you have to write F net is equal to ma, or you can see that the only force in the horizontal direction is the frictional force, and that will be equal to its mass of A into acceleration, or the maximum acceleration that can be provided by the frictional force, right? So FL, we know it as 2, mass of A is 1, so anyways the maximum acceleration will be 2 meters per second, right? 2 meters per second square, right? Fine. So step 3 also complete, right? No issues over here. Let's come to step number 4. Okay, here you have to write F net equals ma for block B. Okay, so far we considered block A for these two calculations. Now it's the time for block B, because we need to find this maximum force, right? So in this question we have to use F max minus the frictional force due to the block, right? Due to this block. Okay, I missed out one force. It's the frictional force due to the ground. Okay, let's name it F dash. Okay, there will be friction on this block due to the ground as well, right? The ground is not moving. When you slide this block on the ground, ground is not frictionless this time, so there will be a force on this block due to the ground too. Okay, so that is the force over here, which is F dash, and yeah, so those are the forces in the horizontal direction, F max minus the limiting friction due to the top block. Okay, and this again, okay, this friction is due to the ground. Okay, and that will be equal to mass of B into the acceleration. Now these two blocks move together, they will have the same acceleration. So this acceleration just will be A max, right? So mass of B is 3, acceleration is 2. Okay, F max we are supposed to find the frictional force due to the block B. Due to block A is the limiting friction, which we have already found out, 2 newtons again, minus the frictional force due to the ground. Okay, due to the ground, you can see it will be mu n, where mu is this coefficient of friction. Again, here it's the same value, but keep in mind that this mu should be now see the surfaces that are there in contact, right? It is this frictional force is due to this block and ground, right? So mu you should consider for this surface. Okay, so F max minus 2, mu is 0.2 into n. N will be ma plus mb into g, right? This normal force is balancing the normal force due to the ground is balancing both the weights, right? So ma plus mb, so 3 plus 1, 4 into g. So 4 into g, okay, fine, 3 2s are 6. Here you will get F max is equal to minus 2 and weight. When you multiply 10 over here, it's 2, 2 4s are 8, 8 and 2 minus 10 and 6. So F max is nothing but 16 newtons. Okay. So option B, 16 newtons is the correct choice over here. Okay. So just follow this procedure step by step and you'll have your answer. Okay. It's very, very simple. Let's step up the level now. So question number 3, you can see that this question is leveled up now, not because the procedure is erased, but because it is a different type of question. Okay, you can see that here we are already given the force. Okay, and by the way, we are not confirmed whether this is the maximum force or not. Okay, it can be anything. Okay, it's just a random force that is applied to this block. The masses of the blocks are given, the coefficient of friction between different surfaces are given. Okay. Here you are supposed to tell what is the acceleration of each of the block. Okay, so how will you go about this? In fact, you can pause this video over here and try this as a challenge. Okay, I'll do it in 3 2 1. Okay, let's try it out. So the idea behind this is to break down this question into the original format. Okay, so what I'll do, I'll just draw it again. I'll replace this 50 Newton by F max. Okay, and the idea is first we'll find the maximum force, right? Why? Okay, let me tell you why. First, let me write this down. Okay, so first we will find this maximum force. Okay, and then we'll compare this maximum force with 50. Okay, whether 50 is greater than the maximum force, 50 is less than the maximum force, or is it equal to the maximum force. Okay, because if you see now when we solve this, let me tell you the answer will turn out to be 45. Okay, and if you see we have applied a force of 50, we have applied a greater force than the maximum force, right? So what will happen, the thing that will happen is this will slide, right? You have applied a greater force, so it will slide. Okay, and the two blocks will have different acceleration because it is sliding. They will have different acceleration. When they are moving together, they have the same acceleration, right? So first of all, let me tell you how we get this F max as 45. It's by following the same procedure, right? So first step, draw the FBDs. So, and then you'll use, okay, we'll come to that later. First, let's draw the FBDs. On block A, you will see that the only force is the frictional force, right? Now we are master of this. You know this. So on block B, the force will be F max, and opposing this will be the frictional force. Now here we have considered F max, so this will be limiting friction, right? And now let's find this limiting friction. Limiting friction is mu into n. Now here you are supposed to draw n and mg, m mass of A into g, and from this block we can find the limiting friction as mu if you see between the two blocks, right? Limiting friction between the two blocks. So between two blocks, mu value is 0.2. N equals ma into g. M mass of A is 5 and g is what? G is 10. Okay, we'll take it as 10. 5 2s are 10. This is 1. Okay, and this will be 10 newtons. Okay, so limiting friction, we found it out to be 10 newtons. Okay, so limiting friction between the two blocks is 10 newtons. Okay, third step is to, what is the third step? You just equate this FL equals m into A max, right? You choose the block on which the only force is the frictional force, block A, right? So in the horizontal direction, you can write the net force FL equals mass of block A into the maximum acceleration that the frictional force can provide. Okay, so A max, from here you can find it as 10 by the mass of A. Mass of A is 5, right? So this is 2 meters per second square. Okay. Now fourth step, what is the fourth step? Right, F net equals ma for the other block. Right, this is the other block. So F net, which is F max minus the limiting friction, right, minus the friction due to ground. Why do I forget that? Okay, F dash, there is friction due to the ground as well, right? This block and ground, there will be also a friction. So minus that too will give you mass of b into acceleration, right? And this will be the maximum acceleration. But because we are assuming, we have broken down this question that this is the case and these two blocks are moving together, okay? And this is the maximum force at which that is the case, okay? Beyond that force, that can't happen, okay? Okay, so F max minus the limiting friction, we found it out as 10 newtons minus F dash. F dash is this, the friction between block B and ground, okay? Now here you can see that this is the normal force, and this normal force due to the ground on this block will balance both the weights, right? Ma plus Mb into G, right? So Ma plus Mb, so 10 plus 5, 15, 15 into G, that will be, okay, I'll find it out. So frictional force F dash will be mu into N, right? So mu between these two surfaces, 0.1 M into G, Ma plus Mb into G, Ma plus Mb, 15 into G. So this becomes 1 and the answer is 15 newtons, okay? So here you'll have 15, right? F dash is 15. MB mass of B is 10, acceleration, maximum acceleration 2, this is 20, 20 plus this is 25, 20 plus 25 is 45, right? So that is what I was saying, 45 newtons, okay? So the maximum acceleration that can be the maximum force that can be applied for these two blocks to move together is 45 newtons, okay? But we have applied in this question, if you see, we have applied a force 50 newtons. So what will happen? The blocks will slide, okay? So the idea over here is that these blocks are going to slide. Let me just clear this off, okay? So this is the thing that we have found out, okay? So now in order to find the acceleration of each of them, let's just draw the free body of each of them. So first, the 5 kg block, as you can see, the only force acting on it will be the frictional force. Now in this case, since there is sliding, it will be the kinetic friction, but here we are not given the values of static and kinetic friction separately, so we'll use the same value of F, right, which is mu into N. We'll use the same value of mu basically. So mu is 0.2, N is again mg. Mg, you can write this frictional force as mass into acceleration, mass of block A into acceleration, right? So mu is 0.2, N is m into G, right? N is balanced by m into G. So it's m into G, right? So basically you will get the same thing as 10, the frictional force as 10 and the acceleration as 2 meters per second, right? So this is 10, right? Yeah, this is 10 and acceleration will be 10 by the mass of A, which is 5, which is 2 meters per second square, right? So this is the acceleration of first one. Now there is sliding, acceleration of B will be separate, so don't conclude from here. The acceleration of B will be, you again have to write F net equals ma, okay? So whenever you are asked for acceleration in block over block, write F net equals ma for this one and this one, the second one, block B, right? Block B, if you see, it has the force 50 Newton in the forward direction, F dash in the backward direction, F in the backward direction, right? So F net equals ma, mass of B into the acceleration. Here it is the acceleration of 2. We are supposed to find this A2. You can see that F net in this case is 50 minus F dash minus F first of all. So F is, we know, 10, right? From here we know the frictional force is 10, right? From here FL is 10, right? Or F is 10, okay? So if you see f dash we have already calculated, it's 15. Okay, the frictional force between the ground and your block B. Okay, that is 15, and mass of B is what is that? Mass of B is 10 and acceleration is a2. Okay, acceleration we are supposed to find 50 minus 10, 40, 40 minus 15, what is that? What is that? 25. 25 by 10 is 2.5 meters per second square, right? If you see a2 is bigger than a1, because yeah, it is pulled by a greater force, right? So this will slide faster and this will be left back because friction is not able to support. Again, this is verifying that fact, right? A2 is bigger than a1. Okay, now, so this is the solution. This is how you do it. First of all, find f max. Okay, let's just revise. F max will break down this question into the questions that we have discussed. Find f max. See if this f max is greater than or less than. So if it's so in this case, you can see that the applied force is greater than this maximum force, right? Applied force is greater, which means there will be sliding. If you pull it faster, right? If the force is greater, then you'll have sliding. Okay, and f max, if f max was less than or equal to, there won't be sliding. The two blocks will move together and will have the same acceleration. In this case, we have two different accelerations. Okay, now for you, a homework problem, you can take this value as 10 newtons. Okay, now you can see that this is less than f max, so the two blocks will move together and you have to tell me the acceleration of each block. You will simply know that the acceleration of both the blocks will be the same, right? Whatever value it might be, they will have the same acceleration, right? So tell me the value of the acceleration in the comment section below, and the correct answer will receive a heart from me. Okay, again the same question, I have just replaced this 50 newtons by 10 newtons. Tell me the value of acceleration. Okay, so yeah, that's pretty much it for today's class. I hope you were able to understand this topic. Now go ahead and practice more such type of questions. Discover the joy of doing it yourself and you'll be able to do it this time because you know the concept, right? And yeah, I'll see you soon in the next video. Till then, keep enjoying physics.